Hey guys, so yesterday we talked about greatest common factoring polynomials, but today we're going to look at how to fully factor a polynomial into two binomials. So this is factoring in the form of x squared plus bx plus c. And then once again, we're going to build off of this tomorrow. The method that we use to factor this, rather than greatest common factoring, is actually called the ACB method. And the ACB method is something that you will continue to use to factor into grade 11. So make sure that you recognize the name ACB factoring and that you know all of the different steps. There are quite a few steps, and you're going to start off by reading through the order of the different steps, but try not to just memorize the order on a piece of paper, but just practice doing it over and over and over again. And eventually it'll just become second nature on how to do this. Also, we are going to be looking at a bunch of different types of polynomials to factor, and the ACB method works with all of these different types of polynomials. That's why that's the method that we teach. But there are definitely shorter methods for some of the other types of special polynomials that we'll be learning about later. So you can use some of those shortcuts later on once we get to those. But the reason we don't teach those is because then you have to learn 5 or 6 different methods of factoring instead of just learning the ACB method, which works for all the different types of polynomials. So I would recommend just always using the ACB method because it will always work, but there are definitely shortcuts that you can take for some of the other types of polynomials we'll learn about later on. Okay, so this is lesson 3.5, and this is the ACB method of factoring polynomials. So the first thing that you do is you make sure that your polynomial is in the correct order, which is with your x squared first, then your x, then your constant. So we already have that in the correct order for this example, our x squared first, then our x, then our constant. The second step is the AC part of the ACB method. It's when we multiply A times C. And so we go over to the side and we do A times C. Now when we're doing this, anything that's in front of the X, so the coefficient of X is our A. Whatever's in front of our X squared is our A value, so the coefficient of X squared is A. Whatever's in front of our X is our B. So the coefficient of x is b, so in this case the -2. And then our constant, whatever's in that last position, is our c value. So when we do a times c, we're looking at what's in front of the x squared times the constant. If there's nothing in front of the x squared like this, then it's just a 1. So we're going to do 1 times -8. Remember, the sign always goes with whatever is directly behind it. That is important. So AC is -8. Okay, so we've done step number 2. Now we move on to step number 3, which is writing out or identifying the factors of AC. In this case, it'll be the factors of -8. Again, I'm just going to do this off to the side. So the factors of -8 are all of the things that multiply to give me -8. So for example, I could do 1 times -8 or 2 times -4, anything that can multiply to give me -8. I could also have -1 times 8 or -2 times 4. My next step is going to be to identify which of these pairs of factors add to my B value. And remember, my B value is whatever is in front of the X. So in this case, it's -2. So I need to know which of these pairs will multiply to -2. Right away, I know that because my answer has to be a negative number, it's going to be one of the pairs of factors where the bigger number is the -1. So it's definitely not going to be the bottom 2. I actually would have looked ahead to see that right away and wouldn't have even bothered writing out factors where the smaller number is the -1 because I know it has to add to a negative number. So that'll save you some time. If you just look at what it has to add to, if it needs to add to a negative number, you're not going to multiply a small negative by a big positive number and get it to add to a negative. And then 1 plus -8 is -7. 2 plus -4 is -2. So this is the pair of factors that add to my b value, okay? Those add to -2. My next step is to rewrite the original polynomial, keeping the ax squared and the c. So I'm going to keep my first term and my last term the same. But instead of writing bx, I'm going to write the factors, placing the variable after each. Okay? So what that means is I'm going to keep my x squared. I'm going to keep my -8. But where this -2x is, I'm now going to write in these factors, a +2 and a -4. Those are my two factors, and I keep my variable, which was an x, with both of them. It doesn't really matter what order I put these in. However, I know that -4 and -8 go really well together because I'm going to be dividing these later on. So that's why I've written them in this order. That's what it means when it says place them in a way that will make it easier for factoring. So put numbers together that divide by each other really nicely. Step 6 is break the new polynomial in half. So between the 2x and the -4x, I'm going to divide my polynomial in half. Then it says factor each half of the polynomial so that you have a monomial and a binomial form on each half. So I'm going to just look at this part here, my first half, x squared plus 2x. And I'm going to see what I can factor out of this using my greatest common factoring. Now there's no number here in front of the x squared, so I'm not going to be able to factor out a number. I can't divide anything by what's not there. However, this first term has an x squared and the other term has an x, so I can take an x away from both of them. So x is going to be my greatest common factor of this first half. And then of course I'm going to write whatever I'm left with in my brackets. So x squared divided by x, again, that's really the 2 minus the imaginary 1. Leaves me with x to the power of 1, or just x. And then positive 2x divided by x leaves me with just plus 2, because my x's will cancel out. Then I'm going to look at my second half, the -4x minus 8. And I'm going to see what can I factor out of that. So what can I divide both -4 and -8 by? Specifically, what's the biggest number I can divide them both by? And the answer is, of course, -4. And then I actually divide it. So -4x divided by -4 leaves me with just x. -8 divided by -4 is plus 2. So now I factored both of my different halves. Step number 8 is make sure that each of the binomials are the same. That means that this bracket here and this bracket have to be the same as each other. If they're not, you've done something wrong. It could be that you factored out a +4 here instead of a -4, which would make your signs wrong in the second binomial. So if your binomials don't match, go back and check your factoring from the previous round. Go back and check your factors from over here. Something has gone wrong. But if they're the same, then you can move on to the last step, which is to write the monomials from each half of the factor as a binomial, and then write the other binomial. So what that means is I'm going to write these repeating binomials. I'm just going to write it out once. Okay, so the repeating ones I write out once. And then whatever was outside of the brackets, those are our monomials, whatever was outside of the bracket gets written as the second binomial in our answer. So this and this form our final binomial. And then that is actually our answer. When you have two binomials like so, you have finished. If you have time on a test or quiz, it's always a good idea to check your answer, and we can do that by foiling. So I'm going to write out my answer. And then when you FOIL, which is also sometimes called the rainbow method, I'm going to start with the first term of my first binomial, and it's going to get multiplied one at a time by both terms in the second polynomial. So x times x is x squared, and then x times -4 is -4x. Then I move on to the second term of that first binomial, and it's going to get multiplied one at a time by both terms in the second binomial. So +2 times x is just +2x, and then +2 times -4 is -8. And then of course I simplify by adding my like terms together. These two in the middle are like terms. So I'll keep my x squared, and then -4x plus 2x is -2x, and I'll keep my constant at the end. This answer that I just got when I FOILed is the same as the polynomial that I started off with, which means that my answer was correct. Okay, so that is factoring using the ACB method. We will be adding 1 or 2 steps onto this in tomorrow's lesson, so please make sure that you practice this lots and have it down pat before you move on, and let me know if you have any questions.